Lesson 4-1. Apply angle sum properties. Classifying triangles by their side. There are two different ways of classifying triangles. One is by the sides and one is by the angles. When we classify our triangles, we usually do it by sides and angles. This is by sides. Notice the first picture. There are no markings on it. That is, no two sides are scalene triangle are congruent. No two sides of a scalene triangle are congruent. Second picture, look at the two markings. There are two sides that are congruent. At least two sides of a blank are congruent. Isosceles triangle. So when you have an isosceles triangle, two sides are congruent. Look at this picture. All three sides are showing as congruent. All the sides of a blank are congruent. Equilateral. An equilateral triangle has all sides congruent. Now this is by classifying by the angles. Look at the first picture. All the angle measures are less than 90. So in a blank, all of the angles are acute. That's known as an acute triangle. The second picture is one angle and only one angle measures greater than 90. In a blank, one angle is obtuse. An obtuse triangle. Look at this third picture. One angle measures 90 degrees, and only one. In a blank, one angle is right, in a right triangle. So you can classify your triangles using both of them. For the first one, the acute triangle, I can have an acute scalene, acute isosceles, and of course my equilateral will always be acute. In the obtuse, I can have an obtuse scalene, I can have an obtuse isosceles, and I cannot ever have an obtuse equilateral. In a right triangle, I can have a right scalene, and I can have a right isosceles. And again, I will never have a right equilateral. Now, the reason why I can never have a right equilateral is because if all the sides are equal, all the angles are equal. So all the angles would each be 60 degrees, so that would make it acute. When the sides of polygons are extended, other angles are formed. So look at these two triangles. In the first picture, see how the sides are extended? Well, the original angles that were in the picture are known as interior angles. Those are the ones that I have colored blue. In the second one, those are the ones that we talk about with exterior angles. Now, the exterior angles and the interior angles are forming linear pairs. Let me show you in a diagram. So this angle that I have colored along with the interior angle form the 180. That's known as the exterior. Well, we can look at it on the other side. It's vertical angle. The vertical angle also, along with that interior angle, adds up to equal 180. It's a linear pair. So we have other ones that are formed by the other extended lines. Theorem form 1 is the angle sum theorem. The sum of the measures of an angles of the triangle is 180. So in this picture, we can say measurement angle W plus measurement angle X plus measurement angle Y equals 180. This applies to all triangles. All the angles of a triangle add up to equal 180. Now the next theorem, theorem 4.2, is known as the exterior angle theorem. Now this is talking about the exterior angle. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Well, let's talk about that for a moment. Your exterior angle in this picture is angle YZP. It's the angle on the outside. The interior angles are angle Y and angle X. So they're saying if I add those two angles, it will equal that exterior angle. Here are two corollaries. Now, a corollary is new to you. A corollary stems from a theorem. It still needs to be proven. It's not like a postulate. It has to still be proven. So in the first one, it's talking about the acute angles of a right triangle. Well, when you have a right triangle and that H, notice, is a 90-degree angle, then the other two angles, if they're going to add up to equal 180 along with H, must be complementary. That is, measurement angle G plus measurement angle J should equal 90 degrees. Now the other one talks about the acute right triangle. When you have an acute right triangle, there can only be one right angle. There never will be an obtuse right triangle because it has to add up to equal 180. So if you have 90 and 91, that's already over 180, and that's only two angles. And you have to have three angles in a triangle. So measurement angle M and measurement angle L should be acute. Now the other one, on the obtuse angle, you can only have one obtuse angle, and the other two must be acute for the same reason. If they have to add up to equal 180, and in this example you already have 142, well, 180 minus 142, and you have to have two angles, have to be acute. You cannot have even 91 and 91. It's over 180. Lesson 1-6. We're jumping back because I saved this lesson to be with Chapter 4 since we're talking about polygons. Here's your essential question that you're going to have to answer at the end of this lesson. How do you classify polygons? In geometry, a figure that lies in a plane is called a plane figure. Now, this is the definition of a polygon. It's a closed plane figure. Closed. And it has the following properties. Each endpoint of a side is called a vertex. Please notice the plural of the vertex is vertices, and we name our polygons in consecutive order like A, B, C, D, and so forth. It's formed by three or more line segments. So you must have line segments for its sides, and it has to have three or more sides. Each side intersects exactly two sides at one each endpoint, so that no two sides with a common endpoint are collinear. So basically you're going to have angles. You're going to have angles all intersecting to form a polygon. Here's some examples of polygons and non-polygons. A circle, is that a polygon? No. It has no sides. Is this shape a polygon? No, it has to have at least three sides intersecting to close it. Is this a polygon? No, this is two polygons intersecting, but when you look at it as a whole, it's crossing through the middle. You cannot have a polygon that crosses like an X. It has to have an open interior. Is this a polygon? Yes, it has sides, it has vertices, and it's closed. How about this one? Yes. Notice that the lines are not intersecting on the inside unless, of course, we extend them, which we have not in this picture, so it is a polygon. Now there are two different types of polygon, the convex, which is that first picture, and concave. Now convex by definition is if I extend each one of these lines of the shape, they should not intersect on the interior. So there are extending the lines, and notice they do not intersect on the interior. The concave, when I extend those lines, look what happens. They did extend on the interior, so that's concave. Now there are different types of polygons. There are a lot more you can Google. They have plenty of names, but these are the most common ones. 3 sides, triangle. 4 sides, quadrilateral. 5 sides, pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. 11 sides, hendecagon. 12 sides, dodecagon. After that, there are names, but we don't usually name them. We just call them n-gons, such as 13-gon, 14-gon, 15-gon, etc. The term n-gon is referred to where n is the number of polygon sides. It can also be used to name the polygon. So as I said, if it has 13 sides, we would call it 13-gon. If it has 4 sides, we would call it a quadrilateral. Equilateral polygon. When you see the term equilateral polygon, that means all the sides are congruent. When you see the term equiangular polygon, that means all the angles on the inside of the polygon are congruent. An equilateral polygon, an example of that one, would be a rhombus. All the sides are congruent. An equiangular polygon, where all the angles are congruent, an example of that is a rectangle. All the angles are congruent. Now, a regular polygon has to be convex. It will never be concave. It is both equilateral and equiangular. That one, a good example, is your square. It has all sides congruent and all angles congruent. This also is your equilateral triangle, where all the sides are congruent and all the angles are 60 degrees. It's actually a regular polygon. We just call it equilateral.